Okay, folks, we're going to get started. Okay, we're going to try to catch up on time. Our next speaker is Sophia Porter. She is going to be a student at Johns Hopkins across the street, so hopefully we'll have her around for a lot longer. She worked with Lou Strolger, Jill Lagerstrom, and Sarah Wiseman, and her project is on Hubble keyword analysis.
Thank you, Lisa. So like she said, I've been working on Hubble Keyword Analysis Project, or HCAP. So the way HCAP works is it's a naive Bayesian classifier that takes incoming Hubble proposals and sorts them into 6 science categories that we have listed over there. In the past, it's been a problem where incoming Hubble proposals have been misclassified, and so it takes a lot of man-hours in order to reclassify them into their proper categories so that they can be looked through and the proper ones selected to move on. So this software goes ahead and sorts them automatically, and it works in 2 steps. The first step is training, so we feed in a number of pre-classified proposals. The classifier breaks them down into what we call a bag of words, which is basically just a frequency count, how many words and which words are in each type of proposal. So of those 6 categories, we look at the words that are found in each of the proposals, and we build up a model using Bayes' theorem, so a probability for each word that it falls into any of the 6 categories. One caveat to this is that Bayes' theorem does assume independence between words, which is never going to be the case. For example, if you find peanut butter in a document, you're more likely to find jelly. So we never actually do fulfill the independence assumption, but since the dependencies are evenly distributed, it actually doesn't make that much of a difference, and we're still pretty successful in classification. The second step is testing on a number of unclassified proposals. So again, we break these proposals down into the bag of words, and then we combine the individual probabilities for each of those words into one overall probability for the document that it falls into any of the 6 science categories. We do that using Fisher's method, and we can actually make some improvements to this process. Stop words are one such improvement, so words like a, the, and that don't necessarily contribute to any specific category, we just remove them outright, so they don't receive a probability at all. We also take words that we call stem words, things like galaxy, galaxies, and galactic that have similar meanings and don't necessarily contribute to proper categorization. We shorten them to a simple prefix, so to speak, in this case, galaxy with an I. We also use primer words. Before we even begin training, we prime the program by saying, these are words you might expect to find in this category. For example, hot Jupiters would be found in planets. So we can guide it as it trains to get even better results. We do have a limited number of proposals to train on just because we don't receive infinite Hubble proposals to begin with. So I decided to set a cutoff at the last 5 years of data. Beyond that, it's not necessarily completely relevant and we don't want to train wrong. So I've taken 5,000 proposals from the last 5 years, and I went ahead and plotted the failure rate, or the misclassification rate, when you train on 500 versus 5,000 proposals. In this case, as expected, you have about 15% failure when you're training on just 500 proposals, and closer to 3 or 4% failure when you're training on 5,000. So that's an exponential curve, and generally I'll stick with about 4,500 to train on so that I can test on the remaining 500 and really figure out what my misclassification rate is. Here's a better plot of the success and misclassification. So again, that's 4,500 training proposals from the last 5 years and 500 testing proposals. In this case, 84% of them were classified correctly by the software on the first try. 3% of them failed, and then we have this middle area where some proposals actually do straddle more than one category, and so even though they're not correctly classified as they were, they may still be correct. So that's that yellow space there, where the correct category was somewhere within the top 60% of the program's guesses. But I do want to focus on this 3% failure. In some cases, the failure is actually one of the greatest successes of the program, where we've assigned a different category than the proposal actually came in with. And that's the whole point of the program, is finding proposals that were miscategorized in the first place and reassigning that category. So that's the whole goal, and up to 50% of these, as I've gone through and picked through them by hand, were miscategorized by the proposers and caught by the program. So that's exactly what we wanted to happen. Fine-tuning can also further improve these results, things like changing stop words, changing primer words, all very minor impacts, but they do add up, so that's something that I'll continue to work on this summer. And Cycle 24 has a really clear application for this software. If we continue to have proposers assign a category to their proposals and we run them through the software, we would expect to see about 16% of those would get flagged as mismatches. And so those could be things that someone would sort through by hand. But that's much easier than looking at 100% of proposals and saying, I don't know which ones are right. So ultimately, this does have bigger implications. One project that I'm going to continue to work on over the summer is actually classifying the reviewers based on papers that they've published in the last 10 years. You can just run them through the same program and figure out what their areas of expertise are. And then you can match up reviewers with proposals and create tags that aren't necessarily with these known 6 science categories, but that are kind of arbitrary based on which reviewers and which proposals we happen to have for that year. Overall, we could actually extend this software to networking all existing proposals and all future proposals that come out, and papers and publications, figure out who does what in this field and what gets published every year. So we could really create a dynamic network of understanding of the field. So ultimately, I think that's a really exciting prospect, and I look forward to continuing to work with the software. I would like to thank Dr. Strolger and Jill and Sarah for all their help, and I look forward to continued success over the rest of the summer. Thank you.
Questions? Let's do Helen first.
Why do you think it is that astronomers are misclassifying their participants?
Generally, there are 2 reasons. Sometimes it's unclear. Some things might fall into AGN and might fall into galaxies, and there's kind of a fine line, especially if you're doing quasar absorption lines. It's unclear whether that would be an AGN and quasar proposal or an intergalactic matter proposal. So some of them do get a little bit fuzzy. Another case is that sometimes people kind of want a leg up, and so if you know that there will be fewer proposals in one category, you might try and slip in into that category to see if you can get a better chance.
Anand?
So related to your answer, are there any, other than with cosmology and AGN or AGN galaxies, are there any other pairs that were commonly shared?
Stellar populations and stars also tend to have a lot of overlap, and that tended to be really confusing for the program. In fact, here, stellar populations especially tends to have a relatively high misclassification rate just because the program can't necessarily tell and the proposers can't always tell either.
Gabe?
Could your machinery at all predict what will be a successful proposal before I submit it?
That would be interesting.
Austin?
You mentioned people will try to misclassify their proposals as sort of little leg up, say a slightly easier field to get accepted in or some such. Is there anything that would stop them from, say, entering a bunch of keywords since the robots will be sorting it instead of an actual person looking through to call them on it?
There's not necessarily anything to stop that, but I think we have enough safety mechanisms in place where if you knew exactly what you're doing and you classified your proposal in such a way that it would match up here, even then it still has to go through the whole review process. So I think it's iffy as to whether that would really help.
Yeah. And playing games like that, astronomy is a very small field,
That's
so
true.
you
Be
get
careful.
flagged very quickly as, oh, that person's going to try to do that. So, Will?
Did you use, or does the software use Python's NLTK library for the underlying language processing?
I believe we're using SciPy.
Oh.
Will, did you have a question? Eddie?
I just want to comment on your question, your response. Like, you've described exactly because 90% classifiers were used as spam filters early on. Like, you described exactly the spam filter arms race. That has gone over the past 2 decades.
I really like that not to happen in proposals.
We're slow.
Well, and what's nice about this is that it can learn as we go along, just like spam filter works. So as soon as you find a way to circumvent that, we can kind of add that into the primer words or train based on whatever method you've figured out. So it is an arms race in a sense, but it does catch up.
Anyone else? Okay, let's thank our speaker again.